Hi, today we are looking at section 8.6, which is scale factors and three-dimensional objects. So we'll be looking at the surface area and volume of our three-dimensional objects. So we will review our formulas for these. So if we have a rectangular prism, our surface area is 2 times the length times width, because essentially we've got this length times this width, which would be our bottom, and then we've got our top, so that's why we've got 2 of it, and then length times height, so that would be essentially area of this, but you also have area of the back, which is once again 2, and then height times width, so we've got this side and then that side, so that's why we have the 2 in front, so it's 2 times length times width, plus length times height, plus height times width, and our volume is our length times our width times our height. Next, we have a right triangular prism. Now, our surface area is our base times height, because essentially we've got a triangle here, which the area of it would be 1/2 base times height, but we've got 2 of them because we have 1 on each side. So when we multiply 1/2 base times height by 2, we get base times height. And then we have length times A plus B plus C, because essentially we can think of these sides of a triangle if we pulled it out into a straight strip. We would have one dimension, which would be L, and the other dimension of it would be the addition of these sides, creating a rectangle. And there's our area of a rectangle. Now for volume of a triangle, essentially we're taking our area of this end, which is 1/2 base times height, and then multiplying it by our length. Now we also have right cylinders, which our surface area is 2 pi r squared, which we know that each circle is pi r squared. So we've got one circle on the top, one on the bottom. So that's why it's 2 pi r squared. And then this here is the area of the sides, because we know the distance around the cylinder is 2 pi r. And then we're multiplying it by height, because essentially if we unrolled this, we would have a rectangle. So this would be our length times our width. Our volume, we're taking the area of a circle, which is pi r squared, and then just multiplying by our height. For a pyramid, our surface area is L squared, which is our base, plus 2 times L times this diagonal height from our base up to the center of pyramid. And our volume is 1/3 our length squared times our height. We have a cone. Our surface area is pi r squared, which is our circular base, and then plus pi r s, which is the sides of our cone. Our volume of it is 1/3 pi r squared h. So our volume for a cone is similar to that of a cylinder, just we have this 1/3 in front. Surface area of a sphere is 4 pi r squared, while our volume is 4/3 pi r cubed. Okay, so next we will look at utilizing some scale factors with some examples. Okay, a blueprint for a water tank is given. If it uses a scale of 1 to 20, how much sheet metal is needed to create it, and what volume will it hold? So this is for measurements from our blueprint. So this is our old radius. We're using a scale 1 to 20. So therefore, to get our new radius, it's going to be our old radius of 0.25 meters times 20/1. So its actual size when it's built would be 5-meter radius. So that was our radius. This is our height. So to get our new height, We are once again using that scale factor and then the distance off of our blueprint. And that's giving us 15 meters. Now we want to know how much sheet metal will be needed to create it. So we have a surface area that's 2 pi r squared plus 2 pi RH, and we'll substitute these values in. So we have our surface area is 2 pi times 5 squared plus 2 pi times 5 times 15. And that gives us a surface area of 628 meters squared. So that's the area of the metal needed to create this. Now our volume is pi r squared h. So that's going to be pi times 5 squared times 15, which gives us 1,178 meters cubed. So it can hold this volume of water. Now, if it actually asks us for liters, for 1,000 liters fits in a meter cube. So if we wanted to know how many liters this held, we would just multiply this by 1,000. And we would find that holds essentially 1,178,000 liters.